Hi everyone. Right now we're going to look at multiplying rational expressions by one another. Those are expressions where we have fractions involved and we have fractions oftentimes in the numerator. We have variables oftentimes in the numerator and in the denominator. The approach we're going to take for multiplication is very much like we would do for multiplication of fractions with whole numbers. So for example, if I had 4 sevenths times 3/8, I could just multiply across by the numerators straight across, I'd get 12. If I multiply the denominator straight across, I'd have 56ths. Now this will simplify down. And one thing we could do to make this a little bit neater, and we do quite a bit, is we think about how we can simplify by removing common factors of the numerator and denominator. So for instance, when I look at this, the numerators here, there's the 4 here and the 8 here in the denominator. That's also going to be divisible by 4. So divide the entire numerator by 4, so that just turns into a 1. Divide the denominator, the 8 piece right here, by 4. That turns into a 2, and we're left with 3/14. We're going to use that same approach over here where we divide by any common factors. Okay. In order to do that really efficiently, what we're going to do is we're going to factor each little piece that we have in these expressions. So let's factor x squared plus x. I believe I can factor that as x times x plus 1. They both have an x in there. And the denominator, I believe I can pull a 3 out of there. 3 times x minus 5 is what would be left, times, in the next expression, the 6x is divisible by 6 and the 30 is divisible by 6. So I'm going to factor out a 6, and I'm left with 6 times the quantity x minus 5. And in the denominator, I see what's called a perfect square trinomial. This is one that pops up quite a bit. And that means it's essentially some binomial squared. And this is x plus 1 squared. You can write that as x plus 1 times x plus 1, or just that entire quantity x plus 1 squared with the exponent. I'll write it this way for now for clarity. And you can double check that: x squared plus x plus 1. Sure, x squared plus 2x plus 1. All right, before we multiply across, we're going to cancel like terms just as we did over here earlier. So I notice in the numerator I have an x plus 1, and I have one in the denominator as well. I'm going to cancel them. I notice in the denominator here I have an x plus minus 5, and I have another one over here in the numerator. So I'm going to cancel those. And I also notice that the 3 here and the 6 here, well, I can divide the 6 by 3. So I'll cancel that out, and I'll make that a 2, because 6 divided by 3 is just 2. Okay, so what's going to be left for us to multiply? I have an x and a 2, so that's 2x over, and in the denominator, all that's left is x plus 1. So the canceling of common factors made this a much more approachable multiplication problem. All we had to do was take what was left, and actually that turned into our answer: 2x divided by x plus 1.